Okay, hi year 10s. Sorry I can't be there today, but I've got an online training course that I have to sit through. So this is your video lesson. What I want you to do today is money and unit conversions. So basically how exchange rates for money work. At a very simple level. At the economics level, it's much more complicated, and also how you convert units from one to the other. Now, the textbook itself is a really useful resource for this. I will post this video lesson up on Classroom along with the notes, so you have access to them forever if it's always useful to you. By the way, keep requests coming if you want video lessons on certain things, because I remember maybe it was this year or sometime last year, some students asked me to do a video lesson on factorizing quadratics, and they found it very useful. Anyway, what we've got here is an example exchange rate. So $1 US is equal to 2.72 Lari, or you could just say 2.72 Lari per dollar. So what does that mean? Well, for example, if I put in $100, then I've got to do the same on the other side, right? So what I get is 272 Lari, just like that, okay? But sometimes these questions get a bit more complicated when we've got to work backwards. For example, if we want to say, all right, so if I've got 100 Lari, what if I multiplied this by to get, what if I times 2.72? 2.72 times x gives me $100. I need to multiply by x to find out how much dollars I get. Now, we could say, in this case, oh yeah, it's 2.72 Lari per dollar. So if we wanted to say dollars per Lari, I wrote that wrongly, so dollar per Lari, how do we do that? Well, we just flip the fraction. So we turn the other way. So here we've got Lari per dollar. Remember, the per thing just means divide. So if I want dollar per Lari, I just flip the fraction. So I do 1 over 2.72. And I think the iPad should do that calculation for me. Yeah, it's being very weird. So let me just get rid of that. Get rid of that, just write it again. So 1 over 2.72 equals, gives me the answer. Why are you doing that? I don't know what this is. Oh wow, so it actually figures this out for me. So that means that 1 Lari is 0.37 US dollars. Just for your information, these kinds of questions more often turn up in the calculator paper. So, for example, okay, now I know that so if I want to say, okay, how many dollars do I get for 100 Lari? I just times this by 100. 100 times 0.37, and this should give me 100 times 0.37. That gives me $37 for 1 Lari. Okay? So often they'll ask questions about currencies you're kind of used to. For example, you're much more likely above any other currencies to have heard of US dollars, euros. I'm more likely to have heard of pounds, for example, and these are all quite close together. A lot of you may be familiar with rubles. 1 ruble is worth something like 1 penny in British money, 1 penny sterling. Okay, so another example here, we've got conversions. So 1 US dollar to 0.86 euro. So that is the number of euro per dollar is 0.862. So euro per dollar, did I say 0.62 is 0.86. And if I want dollars per euro, here you are, spelling euro wrong somehow, EUR, it is 1 over 0.86. And then do the calculation. What do we get? Do the calculation. There we go. Solve. There we go. 1.163. So that's the number of dollars you'll get for 1 euro. Okay. So we use these ideas in the kinds of questions you're going to get in the textbook. What I also want to look at is converting units. So when we work with measurements, it's really important that we make sure we use the same units. Okay, so for example, if you add a certain number of meters to a certain number of centimeters, well, let's say 10 meters plus 40 centimeters, you can't say 50 meters, or you can't say 50 centimeters, it just doesn't work. So we need to make sure we're using the same units. So what we might then instead say is 10 meters plus 0.4 meters. There's our 40 centimeters. And so what we get is just 10.4 meters, dead simple. Now thinking about converting units, if we start with 1 kilometer, hopefully you know that 1 kilometer is 1,000 meters, just as 1 kilogram is 1,000 grams. Okay, kilometers bigger. Okay, then you might think, okay, so what's the next unit down that? Well, down from that. So 1 kilometer is 1,000 meters. One of those meters is 100 centimeters, which means that a kilometer is 100,000 centimeters. What you hopefully already know as well is that 1 centimeter is 10 millimeters. So the next level down from that, we're going to go and we'll say, all right, so we times it by 10. So that is 1 million meters. 1 million millimeters. In maths, we usually don't deal with units much smaller than this. You may, in biology and physics certainly, deal with measurements when you're talking about diameters of molecules and this kind of thing, in which case you'd be working down to nanometers. Or in biology, you might be working for diameters of cells, which you talk about micrometers and so on. Okay? So basically, this is how you do the conversion. If you want to convert, for example, let's say 100 millimeters into centimeters, you just divide by 10. Because that is just 10 centimeters. Okay. Again, more guidance in the textbook. This is just me introducing to the ways of thinking about these. Now, here's a typical question involving that kind of skill. Arrange the measurements in size order. So we've got 0.0003 kilometers, 0.31 meters, 35 centimeters, and 301 millimeters. Some of them may be fairly obvious to you to begin with. Here's something which can throw people off. 301 is definitely a bigger number than 0.31, but because we're dealing with different units, it's slightly more difficult to compare them. I'm going to say the best thing to think about for these, if you're not sure what unit to put them into, go somewhere in the middle. So talk about meters or centimeters in this case. You could convert them all into kilometers just fine. I think it's a bit annoying, and certainly we're much more used, if we think about the human scale of things, we're much more used to working in meters and centimeters. For example, our height would usually be measured in meters. The span of our arms, as in the distance between our outstretched hands, more likely to be measured in meters. And distances on the body, more likely to be measured in centimeters. So for example, distance between your eyes, that kind of thing. Length of your hair, certainly in my case, probably less than millimeters, or negligible in this case. Anyway, I'm going to convert these into meters. Now, we think about a kilometre. Think about this one first. Well, that's 1,000 meters. This, remember, in our number system, each place as we go to the right gets 10 times smaller. So if that's 1,000 meters here, there's 1,000 meters. This is going to be 100. This is going to be 10 meters. This is going to be 1 meter. So this is going to be 1 over 10 meters, which means this is 30 centimeters. Suddenly it's a whole lot easier. Again, there's our full meters. That is 1/10 of a meter, or you say tens of centimeters. This next place is centimeters, 31 centimeters. Okay, 35 centimeters, well, that's just 35 centimeters. And 301 millimeters. So hopefully you know that, okay, there's millimeters. This next one is centimeters, so that is tens of centimeters. So we're talking about 30.1 centimeters. So we're going to say from smallest to largest, or least to greatest, to use the proper terms. Least to greatest. Now our least, that is this one. So 30 centimeters. The next biggest, 30.1. The next biggest, 31. And then the largest is 35 centimeters. This is fine, by the way. This is absolutely okay. We've all got the units in here. What you might want to do if you're being really, really thorough is write them in as they were originally. So our 30 centimeters, 0.0003 kilometers is the smallest. 301 millimeters is the next smallest. 0.31 meters, second biggest, and 35 centimeters. That just stays the way it is. So that's one way of doing it. Going to come to a last example here, and we're going to think about areas and cubes. So for example, if I've got, let's just say we've got a rectangle and it is, let's say, 1 meter by 2 meters. So it's area, dead simple, 1 times 2, 2 square meters. But what you might also be asked is the area in square centimeters. Now here's where you need to be very careful. It's very tempting. You've been doing it for years and years. When you convert from meters into centimeters, you just times by 100. We can't do it in this case. It doesn't work in this kind of way because we're dealing with an area. An area grows faster with length. What we need to do is, if we're dealing with square centimeters, we've got to convert our units on each. So that's 100 centimeters by 200 centimeters. So that's 100 by 200, and that's going to give us 20,000 square centimeters. Just like that. If we think about a volume, so I'm going to hastily sketch a cube, or a cube-like thing, cuboid. So, that's not bad. Let's just imagine we've got a, I'm going to say a 12 centimeter cube. Okay? So, first of all, let's get its volume in cubic centimeters. So, cm cubed. We just do 12 times 12 times 12. Now, I'm going to be lazy on this and let my iPad do the math for me. You could do this kind of question could be in a calculator or a non-calculated paper. Get rid of this V thing because it doesn't like that with those calculations. 12 times 12 times 12 equals, what are you going to give me? Solve. 1,728 cubic centimeters. But what if, for example, it's asking for the volume in cubic meters? Okay, why does it erase that result? Whatever. In cubic meters, we're going to have to convert all of our units. So 12 centimeters is equal to 0.12 meters. So then, to get the volume of this cube, it's going to be 0.12, and I'm just going to cube that, equals, doesn't like this thing again, get rid of it. What are we going to get? Solve. So there we go, 0.00173. It should be 28, but it's given us the three significant figures, just as this is 1,728 cubic centimeters. Other thing as well, small detail, is you may be given cuboids. Okay, so for example, that's a cube, fine, but you might be given, I don't know, like 1 meter here. This might be 12 centimeters, obviously not to scale, and this one might be like 21 centimeters. And then if you're going to get the volume in cubic centimeters, you're going to have to do 12 times 21 times by, give you a bit of thinking time, times by 100. And that will get us the volume in cubic centimeters. Solve it. There we go. Centimeters cubed. But of course, you may have to get it in cubic meters, in which case it is 1 times 0.12 times 0.21. Get the result there? Tell me. Solve. Huh? Okay, it's not doing that right. One times 0.12 times 0.21 equals, don't give me a result at 0, solve it. There we go, much more sensible. And that's in cubic meters. One thing you might notice, by the way, is to go from here to here, we divide by 100 cubed. To go from here to here, we times by 100 cubed. Same as in the previous one, so to go from here to here, we divide by 100 cubed, and here we times by 100 cubed. For areas, from here to here, we times by 100 squared, and here to here, we divide by 100 squared. There we go. So, video lesson, and I will see you on Thursday.